Assalamualaikum everyone. Welcome back to my channel. And yesterday, in last video, we have covered our introduction and implementation of assembly language in ATMEGA 328P using AVR Studio and C simulation on Proteus. And now we have move on to our introduction and implementation of C programming on ATMEGA 328P and interfacing 7-segment display with ATmega 328P using Atmel Studio and Proteus. Okay, so the objectives of this is lab number 3, to get started with C language programming for microcontrollers, to learn the basics of basic objective and implementation of C language, and to see the practical implementation of C language. The software requirement are AVR Studio, Proteus, and hardware requirement are this. We will see its hardware implementation. And introduction of this lab is why we need C language. So we have used assembly language and C language. So why we need C language? Earlier, embedded system applications were developed using assembly language programming. However, they did not provide portability. This disadvantage was overcome by the advent of various high-level languages like C, Pascal, and COBOL. However, it was C language that got extensive acceptance for embedded system, and it continues to do so. So, what is C language? C language was developed by Dennis Ritchie in 1969. It is it is a collection of one or more functions, and every function has its collection of statements performing a specific task. Uh, it is memory consuming, but it is user friendly also. The main feature is the software is designed for different keyword data type and variable constant. Embedded system is genetic term to a given programming language written in C, which is associated with the particular hardware architecture. Embedded C is an extension to the C language with some additional header files. These header files may change from controller to controller. C versus LI assembly. We have Fortran, C, and Pascal. These are high-level language, and assembly language is user-friendly, and then machine language, and then hardware. The coding in machine language will be difficult, but it will easy to create to see how hardware work. Then the assembly language and high-level language like Fortran, C, Pascal, and COBOL like this. I am a proponent of assembly language. In reality, I have reached a point in my life at assembly language is a threat to do both financial security and my sanity. Writing firmware in assembly language is slow and error prone, and maintaining an adequate language of abbreviation is long. Complex programs is hopelessly difficult. However, I will certainly insist you cannot really understand high level language if you do not understand assembly language. If you have never had opportunity to gain some solid experience with assembly language, you should at least familiarize yourself with some of the basic concepts before you dive into C. The article listed above in the supporting information section are good to play start. Definitely C program and embedded C program. Generally, the language is used to develop desktop-based application, and then C embedded C is the language used to develop microcontroller. C is not an extension to any programming language, but a general purpose programming language. And embedded C is an extension to programming and features such as addressing IO, FX point, arithmetic multiple memory addressing, etc. Processing net. You can pause the video and read it, and if you have any confusion, you can ask. So these are the some differences between C language and embedded C language. This is assembly language also. These are some advantages and disadvantages of this. And application are the application of IDC programming include the following: embedded C programming used in industries for different purposes. And these are the data types in C: character, assigned character, or ancient character. These are range, and these are the data types, and these are the sizes. Include statement. Every command, every code will start as include statement. Include statement include the library and the different ports selection and sensor or different things we need. If you this is handy way to keep your code organized, and it also allows you to use library functionality, hardware configuration routines, and register definitions provided by the manufacturer. These are the processor definition, processor frequency, and operator condition statement and loops. The loops will be used here, operator and conditional statement also. This is conditional statement. A for loop, while loop are the loops, and operators are these. It's arithmetic operators. This is for loop, and we will create our functions as well. Software procedure we have learned earlier, and Proteus software, Atmel, and both we have learned earlier. So we have task one: write AVR program that send values zero effect to port B. We have started with include library, AVR input output.h, and with main we have character initialize character Z and port B as output. We'll start as with for loop, and we will use our port B into Z, and we have while loop 1. Now the simulation, so this is code, and this will loop run for 255, and this is our sending value to port B, and this is our Proteus simulation. The LED shows 0 FF. FF means all the LEDs are on. The So where task 2 is write an AVR code that send hex value for ASCII characters 0 to 9, A, B, C, and D. So the code for this, here it is the code. So we will start include AVR library main into main, and then create a array with this, and with a for loop with z less than 10, and every value is stored in z and my list, and while one will return 0. And this is the code for storing the values, and this is the Proteus simulation for storing the values, and it's ATMEGA 2560, and here it is showing you in LCD 7-segment display. The task 3 is the write an AVX program to toggle all the bits of bit 200 times. So we'll start with or set output port B and port B into store value 0 cross AA and initialize and send character Z, and it will run for 200 this for loop, and this port B value will be negate with negative port B, and it is stored in port B. So every value is shifted, it means negative, and it is Proteus simulation of this. Task 4 is write an C program that get byte data from port B and then send it to port C. We have port B as output input and port C as output, and then pin B will receive our input, which will go to port C for output. Pin B is port B, and it will send a value to port C and will show the output. And here is a Proteus simulation. Task 5. The task 5 is we have three output port B, C, and D, and we have set values to port C, port D, and port B, and it will show here which we have sent values to port A, port C, and port B. A port simulation with ATMEGA 2560. Then we have task number 6, write and code to monitor bit 5 for port C. If it's high, then send 55H to port B, otherwise send AAH to port B. The code is we have in pin port B is output and port C is input, as well as port D is output. So if pin B is this, this is not equal to 0, then this send 0 cross FF, 0 cross 55, and else 0 cross AA. Let's see our Proteus simulation. Here it is. If it is button is on, then its value is equal to this, and the value is it is open, then the value will be 0 cross AA. Similarly, this is button will be closed, and this is our participation with ATMEGA 2560. Like here, button is off, then we have AA, and button is on, we have 5. Then we have activity 1. Case 1, we have this is the code, and activity 2, we set the frequency and include library and delay library and display function. We have set the ports and higher bit and lower bit case. Here's the digital clock code. We have set the output to different ports A, B, C, D, E, F, and this is a port for higher bit hours, and this is the lower bit hours, and then as well as minutes and seconds per seconds, and as well as call the delay. Then we have character display function, which we have with number is equal to 0, then return 3F. If not, if 1, then 06, if 2, as well as similarly you can see here, send to up to 9, and it is a Proteus simulation of digital clock. It is hours and minutes and seconds. And this is hardware simulation of task 1. This is for task 2, and this is for task 3, and task 4, and 5, and activity 1. So in this lab, we have learned about the programming in C for AVR microcontroller, as well as we have learned about the 7-second display, how to interface using AVR C code, and Atmel. We have seen the practical implementation of C code. Thank you so much for watching. We will cover lab 4, which have introduction and implementation of C programming, interfacing hex keypad with ATMEGA 3.8 using Atmel Studio Proteus. Thank you so much for watching.